Here we have some communication and thinking problems. So there are two questions here, question number 1 and 2. They're kind of related but very different. Now, question number 1 is, the ordered pair 3, 5 belongs to a function f. Explain why the ordered pair 2, 3 cannot belong to f inverse. Copy the question, think about it, and then answer it. Question 2 here is, the ordered pair 3, 5 belongs to a function f. Explain why the ordered pair 5, 7 can belong to f inverse. So these are two questions which I would like you to think about and then answer. And once you have answered, then listen to my views on this, okay? Now this is how I'm going to approach it. When we say that the ordered pair 3, 5 belongs to a function f, then let's say this is our function and this function has a point 3, 5, right? Then what is going to be the point on inverse of this function? So f inverse will have a point 5, 3, right? So that is what that relates, correct? Now the question is, explain why the ordered pair 2, 3 cannot belong to f inverse. So if we have an ordered pair 2, 3 here in the inverse function, then how will it be on the original function? On original function, it will be 3, 2. Now if it is 3, 2, then at 3 we'll have two different values and then function will not be a function. Since we are saying that it is a function, so this point cannot belong to the inverse of the function. The 2, 3 cannot belong to inverse of the function since it contradicts. Do you understand? So if 3, 5 is on the function, then 5, 3 can be there on the inverse of the function. That is fine. But if 2, 3 is on inverse of the function, then that means that corresponding to 2, 3, we should have 3, 2 on the function, right? 3, 2 on the function. But if 3, 2 is on the function, then it is no more a function, because at 3 you can have either 5 or 2, right? Therefore, this is not possible, right? So therefore, this is not possible, right? Now let's look into the next scenario. The other one is, the ordered pair 3, 5 belongs to the function. So its first statement is same, right? So 3, 5 belongs to the function, and therefore this image on inverse of the function will be 5, 3. That's okay. Explain why the ordered pair 5, 7 can belong to f inverse. So that means, can you have f7? 5, 7 on f inverse? If you have 5, 7 on f inverse, then it is not a function. Well, that could be okay, because many functions inverse is not always a function, right? So that seems to be fine. So this is not a problem. The problem is we have to see what actually it is on the function. So on the function, the point will be 7, 5, and that is not a problem. It doesn't violate anything, right? So this could be okay. Do you understand? So that is why I have taken these two examples, on the same page to explain you what could be the restrictions and how we can twist the questions at times and provide reasoning. See, it's kind of similar thing. In one case it is impossible to do it, in the other case it is possible, correct? So that is how tricky inverse functions could be. I hope you enjoy it. Thank you.